In last class, our topic was legacy WAN, traditional WAN. We were talking about traditional WAN like GRE VPN. I had discussed GRE VPN. We have already covered that. Then I had discussed DMVPN Phase 1, if you remember. We had discussed DMVPN Phase 1. What I had told you about GRE VPN? Can anyone explain GRE VPN? GRE or tunnel? Let me ask you some question before we proceed. First question, these are interview questions. First question, what is underlay and overlay? We had discussed this. What is tunnel network? What is GRE? And what is DMVPN? These are the very common question from traditional WAN. Later, you all will learn the modern WAN, SD-WAN, right? The modern WAN is SD-WAN, right? Software defined wide area network, right? This is the modern, right? Again, we'll connect multiple sites. We will have same topology, but these routers will be managed through software, right? In the SD-WAN. That is modern WAN, and whatever WAN technology we are understanding now, these are legacy WAN, is still used in production, right? Many times you will see the legacy WAN technologies running in the production, right? And even to understand the modern WAN like SD-WAN, you have to understand the legacy WAN first, right? So tell me the answer of this question one by one, guys, quickly. Whoever want to try, you can just unmute yourself and speak.
Yeah. Underlay is something which is actual physical network, and overlay is like over the actual physical network, that is a logical connection between two end hosts, or uh, so the that is underlay and overlay.
Great. Anything else? Anything else about underlay and overlay? Which type of network it is, the right now which you can see on the screen? Like 3 router R1, R2, R3, all the routers are connected with ISP internet, right? Fast Ethernet 0/0 of R1 is connected with internet. How will make reachability publicly between these 3 routers? Through default, or first you will configure public IP address on the WAN facing interface, on ISP facing interface, and one default or towards ISP if you want complete internet access from this ISP. If you have dedicated internet connection in any site, in maybe headquarter, branch 1, branch 2, you will not configure the default route. You will configure a route for peer IP address like 2.2.2.0, 3.3.3.0, right? Like this. So which network it is? This is overlay or underlay?
The underlay
Yes,
type
this is
networks.
underlay. Underlay is the physical network which we can see like this one. This is physical network. This is called underlay. Underlay is the physical network infrastructure that carry the actual traffic, right? Even you will create the overlay here, right? The DMVPN or GRE or tunneling, tunnel network, we can say. But your traffic will travel through this network only, right? Can traffic travel over virtual link? No, right? Over overlay? No, traffic will travel on underlay only, on the physical link. It will go through this physical link only. Here we'll create the tunnel, and that tunnel will be reachable from this physical interface. So underlay means the physical infrastructure that carry traffic. Physical network include your physical router, switches, physical cables, right? And core IP connectivity, real IP connectivity. Underlay always ensure reachability only. Reachability, when all the public IP addresses will be reachable with each other, then we'll create the overlay. Underlay is for pure reachability, IP reachability, right? So you can say underlay ensure basic IP reachability between devices, between sites. After that, overlay is virtual network created on top of physical network. On this physical network, what we will do, we will create the virtual network. Same thing will happen in modern WAN as well, in SD-WAN also, right? Similarly, we'll create tunnel network, VPN overlay in SD-WAN, in DMVPN, in GRE VPN. One minute, what happened? Okay, 1 minute, please. Like this is what? Virtual network running on top of my physical network. This particular network is called overlay. In SD-WAN also you will create overlay like this. It can be point to point, it can be multi-point to point, or it can be multi-point to multi-point. On all the router, mode of my tunnel interface can be, what happened to this? Here it's working. No problem, there is issue in my pin. In BGP also we had seen what? Overlay, like when you configure indirect neighborship in BGP, whether it is iBGP or eBGP, that works as a underlay or overlay, like between three router R1, R2, R3.
Yeah, overlay it will be.
Here I have a loop back on router number 1, 1.1.1.1 and 3.3.3.3. Here we have indirect BGP neighborship. It can be iBGP or eBGP. This is also acting as a overlay. On overlay, you can run all the routing protocol, not only BGP. You can configure static routing or OSPF, ISIS, BGP. Like here on the overlay as well, we can have all the protocol. Like you can see now, this LAN is connected to this overlay. This LAN is connected to this overlay. This LAN is connected to this overlay. Again, to exchange these route with each other, we have to configure routing. Either we can configure static routing or OSPF, EIGRP, ISIS or BGP. The most commonly used protocol over DMVPN is, I had told you before as well, EIGRP. The most commonly used protocol over DMVPN is EIGRP. Why? Because EIGRP works best over DMVPN, better than your OSPF, right? But you can configure OSPF as well. As you are learning, you should test all the protocol over DMVPN. Second question is, okay, is overlay clear? Overlay is a virtual network built on top of underlay on physical network. It creates logical tunnels between devices. In GRE, I have told you I have two edge router R1 and R2. Both the routers are connected with internet ISP, right, at different location. ISP1, ISP2. Here I have public IP 1.1.1. Here I have public IP 2.2.2.1. And between these two public IP address, we can create GRE. What is this again? Virtual network, which is running on the top of physical network. And here we have LAN, let's say net A. And here I have one network, let's say net B. Right, so now again we can configure routing protocol here, OSPF or EIGRP or BGP or static routing or ISIS protocol, any protocol for reachability. So overlay creates, or DMVPN, or you can say GRE creates tunnel network. Similarly, you will see in the VXLAN, like in the data center network, you will see the VXLAN virtual connectivity between two devices. In GRE, you have seen virtual connectivity between two edge router. In ipsec also you will see virtual connectivity between two router over public transport. Over MPLS we had seen MPLS L3 VPN, MP BGP VPN between two PE router. All are what? Overlay. Similarly, DMVPN is what? Overlay. Even your MPLS, you had seen in MPLS router was forwarding traffic without having routing table. Works as a overlay. It also create tunnel, like not exact tunnel but the virtual kind of link between PE router for customers, for different customers. Through VPN only, service providers separate multiple customers. Tunnel, what is tunnel network? Can anyone explain the tunnel? Tunnel is overlay. Tunnel is virtual path created between two or more devices. Tunnel is nothing but your virtual network, which is overlay. GRE stands for generic routing encapsulation protocol. In last class we had covered GRE only. If you remember, we had seen the GRE configuration. For GRE configuration, we had created one tunnel interface on router number 1, like interface tunnel 1, and I had configured one IP address on the tunnel interface. I had defined tunnel source, tunnel destination, correct? And how router encapsulate packet? How router encapsulate packet? Whenever exit interface is tunnel interface, router is going to encapsulate IP packet into GRE header, and then it will add outer IP header. In outer IP header, source IP will be the tunnel source IP address, tunnel and destination IP address will be tunnel destination IP address. Both are public. So as both are public, router on the internet can take forwarding decision. They will have route in their routing table. So GRE encapsulate what? IP packet. GRE can encapsulate any IP packet. Inside IP packet, you can have any data, TCP traffic, UDP traffic, or OSPF packet, any layer 3 traffic, right? All L3 packet, IP packet can be encapsulated in another layer 3 IP packet over GRE. We have discussed this. But GRE connect two sides. GRE is point to point VPN, point to point tunnel. GRE is point to point tunnel. After that, if I have multiple sites like 3 sites, then what is the issue with GRE? If I will create GRE here, what is the issue? One GRE over here, one GRE over here, and if I want a spoke to spoke communication, one GRE over here. Let's suppose I want only like branch to branch communication through headquarter, then 2 tunnel is fine. But if I need full mesh topology, I have to create 3 tunnel. In real time, in real time in production, you will have scenario like this. 1 minute. You will have scenario like this. Let's suppose you have one headquarter HQ and 200 branches. If in this scenario, when I have 200 branches and one headquarter, if I will go with GRE, can I go with GRE here? Can I go with GRE protocol?
No, sir.
If I will go with GRE, then what is the issue? If we configure normal GRE here, GRE tunnels, then what is the issue? Then what is the issue? Then for 200 branches, yes, tell me.
We have to create 200 plus tunnels.
200 tunnels, not 200 tunnels only. You need, for 200 branches, you need 200 multiplied by 199 divided by 2 tunnels. Right? See, for 3 sites, you need how many tunnels? For 2 branches and 1 headquarter for full mesh topology. You need around 19,900 tunnels here, which is impossible, which is not possible, right? So we will not go with GRE when we have lots of branches, right? You can still connect to headquarter, to data center through GRE, right? Like if you have multiple hub site, you can have GRE between hub, 2 hub site, 3 hub site, 5 hub site. But when you have 100 number of branches, 200 number of branches, you will never go with GRE. That's why Cisco invented DMVPN. That's why we come up with DMVPN. DMVPN stands for dynamic multi-point VPN. Yes, dynamic multi-point VPN. Actually, like GRE is not secure. What I had told you, how to secure the traffic over GRE? You cannot send company traffic, company data directly on the internet, right? So later you will secure it through ipsec. Similarly, you will secure DMVPN tunnel network through ipsec. So DMVPN is actually combination of multiple technologies. It is combination of 3 major technologies. First one is MGRE. MGRE is multi-point GRE tunnel on one interface. Why it's happened like this? Multi-point tunnels on one interface, like hub router. Multi-point tunnels on one interface is called MGRE. Like this physical interface of R1 F0/0. It's a single physical interface. Here, if you are going to create tunnel and tunnel mode is MGRE, it can create multiple tunnels. Right? That is the meaning of MGRE. The second thing is NHRP. I have told you about NHRP also. I remember. NHRP. Another technology is NHRP. DMVPN is combination of MDRE and NHRP protocol. NHRP stands for Next Hop Resolution Protocol. Next Hop Resolution Protocol. What I have told you, through NHRP, your spoke routers, spokes router discover whom? Discover each other's public IP. Each other public IP. Even through NHRP, a spoke router will register to hub router that, hey, my NBMA address is this one and my tunnel IP address is this one, right? Because in the multi-point GRE, we cannot configure destination, right? How router 1 hub router will get to know about the tunnel destination, right? To encapsulate your IP packet in another IP packet, right? So a remote public IP address will come through NHRP. Like all the spoke sites will register themselves to hub router through NHRP registration message. If you want, you can capture the link and you can see the registration message as well. And the another technology is for the security, like it is just pure connectivity, not secure. So we can add one more technology over here, that is ipsec for encryption, right? That will encrypt all the traffic, encrypt, right? So DMVPN, like before SD-WAN, we were using DMVPN only to connect 200 sites. DMVPN with MGRE, NHRP and ipsec, all was working together. Then I had told you we have 3 phases in DMVPN, if you remember, right? There are 3 phases. In DMVPN. Phase 1, phase 2 and phase 3. Can anyone tell me about phase 1? Phase 1, phase 2 and phase 3. Phase 1. In phase 1, all traffic go via hub router, correct? Go via hub router. In phase 2, like in phase 1, site to site communication is not possible. Spoke to spoke communication is not possible, because in DMVPN phase 1 we configure hub router tunnel interface as MGRE and spoke site tunnel interface as GRE, point to point. So DMVPN phase 1 is multi point to point VPN, multi-point to point VPN, and DMVPN phase 2 is multi-point to multi-point VPN. In phase 2, a spoke can directly communicate to other spoke. A spoke to a spoke communication is possible. A spoke to a spoke direct communication. And DMVPN phase 3 is quite intelligent than phase 2. You will see some issue in phase 2. Phase 3 is solving that, right? So phase 3 uses a feature called redirect. How many of you know ICMP redirect feature? ICMP redirect feature. We had discussed this earlier. I remember. Let's say I have two routers, R1, R2. Router 2 is connected to internet and both the routers are connected to one LAN switch. R1, R2. Here I have internet, ISP, loopback for testing. I have one switch This is just basic question. You guys can try to answer. Switch. Here I have a client machine PC with IP, let's suppose with IP 10.1.1.1 IP address of this client machine, and gateway IP address of this machine gateway IP address is, let's say, 10.1.1.10, and 10.1.1.10 is running on router number 1. Here my IP address is 10.1.1.10. Here my IP address is 10.1.1.20. Right, so on both the router you will configure one default route. Here default route towards ISP, and on router number 1 default route towards which router? Towards R2. If I am going to ping 8.8.8, can anyone tell me packet flow from the user? User will send traffic to whom? Hello.
R1.
R1.
R1. What R1 will do?
R1 will redirect to the R2.
R1 will send traffic from the same interface, from the receiving interface. What it mean? It means someone is using suboptimal path. It mean what? It means someone is using suboptimal path, not the best path. Best path is from the R2. So what R1 will do in this case? R1 will send one ICMP redirect message to PC number 1. Hey PC1, you are using suboptimal path. You know, next hop to reach 8.8.8 is not 10.10. Take another next hop, 10.1.1.20. With the help of redirect message, R1 can inform to the client machine that your best next hop is not me, it's 10.20, and PC will update their cache and it will start sending traffic to router number 2. So first ICMP packet will go via router number 1, second ICMP packet will go via router number 2. This is possible because of ICMP redirect feature. Similarly, in DMVPN phase 3 we have concept of NHRP redirect message, right? You will see this practically. Any question till here, guys? In DMVPN phase 1, phase 2 and phase 3? How to configure DMVPN phase 1? Multi-point VRE on.
Sir, I have a question regarding.
Go ahead. Yeah, if anyone have question, go ahead first.
Okay, so yeah, okay. So I have a question regarding the underlay and overlay. So underlay mostly the physical reachability to the all of the site, right?
Right.
But through the ISP. So means all the site are connected to each other through underlay. So what is the why come the overlay here? Means the reachability is through
For
the
the
physical
private
connectivity is on.
reachability,
Okay.
through underlay there is public reachability. ISP will not allow you to send private traffic. That's why we are creating what overlay here for private connectivity. By default, multiple private sites cannot communicate through public network. The technology which we are using to make it possible is known as VPN, virtual private network. What we are doing, we are creating multiple private network virtually together.
Okay, so means all kind of VPN is work in using the overlay, right?
Yes, exactly.
Okay. And the second question is that the GRE source, tunnel source and tunnel destination IP, the public IP must be in the same subnet, means the same network,
No,
or
it is
maybe
in
they can
different
different.
network.
Okay. Okay.
Here on router number 1, tunnel source will be 1.1.1, tunnel destination will be 2.2.2.1 and 3.3.3.1. Not in same subnet, it is in different subnet.
Okay, so thank you. Thank you.
Welcome.
Yes.
Yes, anything else? Let me access this router. Nothing is configured here. Let me use Notepad for basic configuration. For underlay configuration, R1 config T interface F0/0 no cert IP address 1.1.1.1. Interface F1/0 IP address is going to be 192.168.1.1 255.255.255.0. I'm not going to run BGP here. Remove it. Default route IP route. If you will configure default route, all internet traffic will be routed towards ISP. You already know if I have dedicated another internet in LAN site, right? How will make public reachability? So here IP route 0.0.0. I want internet access as well. You can configure NAT and VPN together. IP route 0.0.0, exit interface F0/0 and next hop IP address 1.1.2. 1 minute, guys. Sorry, see now. हाँ सर चलेगा. Exit. This is my underlay on R1. Copy and paste. On R2, interface F0/0 will have IP 2.2.2. Sorry, 2.1. And here 2.1. Exit interface fine. Next hop IP address is going to be 2.2.2.2. Copy and paste on R2 for underlay. Then R3. 3.3.3.1. 192.168.3.1. Next hop IP address is 3.3.3.2. Copy and paste on R3. Underlay configuration. Now I need to configure ISP. On the ISP router, just I need to configure IP addresses, nothing else. Interface F0/0, no cert, IP address 1.1.1.2 255.255.255.0. Interface F1/1. Again, no cert, IP address 2.2.2.2 255.255.255.0. And interface F1/0. No cert and IP address 3.3.3.2 255.255.255.0. Now you can verify underlay. Let me save the configuration of ISP and close the console of ISP. I'm not going to configure anything else. Go to R1 and ping remote public IP address 2.2.1. Ping is working. 3.3.1. Ping is working. So you can see there is underlay reachability. No problem. Everything is fine. Now let's configure DMVPN phase 1. DMVPN phase 1 on router number 1, what will be my configuration? Interface tunnel 1. Tunnel source fast Ethernet 0/0. Tunnel mode. Tunnel mode is going to be what here? Tunnel mode is going to be GRE multi-point.
NGRE.
Mode GRE multi-point.
Multi-point.
multi-point. Then I have told you to enable NHRP protocol, right? IP, first IP address. What is the subnet for tunnel? Subnet for tunnel is, let's say tunnel subnet is 10.1.1.0/24. So IP address 10.1.1 255.255.255.0. Then IP NHRP network ID. Network ID, let's say 1. If you want to configure password, you can configure IP NHRP authentication Cisco 123 password, right? I am not going to configure it now. Let me copy the command and let me paste it on hub router. Config T and paste. All the commands are accepted. So run interface tunnel 1. Okay. So IP interface brief. Tunnel interface. It's up. Line protocol and status both are up. So DMVPN, nothing is there. Now let's configure a spoke router R2. Config T interface tunnel 1 tunnel source fast ethernet 0/0, and here what will be the tunnel mode? Point to point. So we'll configure the tunnel destination. Tunnel destination will be 1.1.1.1 and IP address 10.1.1.255.255.255.0 and IP NHRP network ID 1. That's it. Go to R3. Config T interface tunnel 1 tunnel source fast ethernet 0/0 tunnel destination 1.1.1 tunnel destination 1.1.1, then IP address 10.1.1.3 255.255.255.0 and IP NHRP network ID 1. This command will enable NHRP, right? What is the issue here now? Will my DMVPN come up? So DMVPN, nothing. So DMVPN, nothing on R1. So DMVPN, nothing. Issue is hub router don't know about destination, tunnel destination. Hub router don't know about tunnel destination. See, before configuring mapping, I am going to capture this link. Capture this link, then go to router number 2, and on router number 2, see what I am going to say. On router number 1, you can verify NHRP table till then. So IP NHRP. NHRP table is empty. Go to R2, go to tunnel interface tunnel 1 and say IP NHRP NHS. Right? I have told you there are two types of router in NHRP, NHS and NH. See, next NHRP server and NHRP client. Next hop server, next hop client. So who will be the NHS server? Hub router. Hub router is going to be NHS. What is the IP address of NHS? See, guys, you will get DMVPN in CCI lab exam as well. You know, sometimes many students did this mistake. They think here we'll define the public IP address, but it will be NHS IP address will be the tunnel IP address, not the public IP, right? What is this? This is tunnel IP address of hub router, not the NBMA address or public IP address. It is going to be not 1.1.1. It is 10.1.1.1. Many times you will get this to troubleshoot in CCI lab exam, right? And like if you will not look at this carefully, you can skip it, right? And you will feel troubleshoot the issue, right? DMVPN will not coming up. So I said IP NHRP NHS 10.1.1.1. Now this router will register theirself on hub router 10.1.1.1. Here you can see the NHRP registration message. Are you able to see the capturing, guys? Who has generated this message? NHRP registration request message 2.2.2.1. See in the outer IP header, IP address is 2.2.2.1. If I will open it, you can see two IP header, like not two outer IP header, NHRP message and IP header. In IP header, source and destination is public. Source IP R2 public IP address and destination IP address is NBMA address of hub router. We have configured this, right? We have configured tunnel destination. So your spoke router will send NHRP registration request message to the tunnel destination IP address, and it is encapsulated into GRE, generic routing encapsulation. This time see in GRE NHRP protocol packet is encapsulated. If I will open NHRP registration request message, here you can see there is some mandatory part. In mandatory part you can see source NBMA address, source protocol address like the tunnel interface IP address, and destination protocol address. Tunnel address is called protocol address, and in the response of NHRP registration request 1.1.1 has here registration reply message, right? Reply message you can see. And now router 1 hub router will start maintaining a table called which table? So IP NHRP table. In NHRP table you can find the NBMA address and protocol address, the tunnel remote tunnel IP address. The NBMA address is 2.2.2.1 and remote IP address is 10.1.1.2. Now if you will check so DMVPN here, so DMVPN you can see one DMVPN is up, one DMVPN session is up with 2.2.2.1. the NBMA address and the tunnel IP address is 10.1.1.2. state is up, and this attribute dim is dynamic. How router 1 has established this DMVPN? Dynamically, because statically also I can map, right? There are two ways to map the tunnel IP address, protocol address and NBMA address, static and dynamic. Statically also I can say IP NHRP map this IP address into this NBMA address, like we had mapped multicast address into the NBMA address in last class, right? Similarly go to R3, and on R3 also I'm going to say interface tunnel 1 and IP NHRP NHS 10.1.1. Now R3 will also send registration request message, and now you can see in the NHRP table of R1 we have two entries, one for 10.2 and one for 10.3. You can see the NBMA address of both, and we will have the dynamic DMVPN here. So DMVPN, you can see two DMVPN. If you have 200 branches, you will have 200 number of DMVPN over here, but we have single tunnel interface. We don't have 90,000 tunnel interface here. We don't have 19,000 tunnel interface. Single tunnel interface is connected with multiple tunnel. 1.1.1 or 10.1.1.1, the tunnel interface is connected with 10.1.2 as well as 10.1.3 with both tunnel. Now when DMVPN is up, like on router number 2 also you can check. So DMVPN, here you will have single DMVPN, nothing is there, because here we have configured the tunnel destination IP address statically. Here we cannot verify the DMVPN, but now we can configure any routing protocol over here. This is DMVPN phase 1. All communication between spokes will happen via hub router. If I will take you to phase 2, what you will do in phase 2, just you will remove tunnel destination IP address from the spoke sites interface. Tunnel 1, here I will say no tunnel destination, or if tunnel destination is configured, can I set tunnel mode and GRE multipoint? Can I configure this? No. Reason? The tunnel destination IP address is configured. Tunnel destination means point to point. Here we have point to point VPN. That's why in DMVPN, so DMVPN output, we are not able to see any VPN. So tunnel interface tunnel 1, and then no tunnel destination. On R3 also say no tunnel destination. And what you will do now, you will configure, change the mode, tunnel mode GRE multi-point. Go to R3 and here also configure tunnel mode GRE multi-point. Go to R1, check DMVPN or NHRP. So DMVPN. So DMVPN, let me send traffic ping 10.1.1.1. Ping 10.1.1. What happened? See, router is not sending ICMP packet. Can anyone tell me why? Because router 2 don't know what is the NBMA address of this IP address. You have removed the tunnel destination, isn't it? You have removed tunnel destination. So you have to configure here mapping. Go to tunnel interface, interface tunnel 1, IP NHRP map 10.1.1.1 into 1.1.1. And now so ping first, ping is working, and so DMVPN. Now you can see one DMVPN over here. On router number 3 also, interface tunnel 1, IP NHRP map, this IP address 10.1 into 1.1.1. We have configured the mapping, and now so DMVPN. Here you can see one DMVPN, and here what is the attribute? Attribute is S stand for static. In DMVPN phase 2, you can see on the hub router we have dynamic DMVPN. On the spoke routers we have a static DMVPN. Statically we have mapped the NBMA address and tunnel address of hub site. Is it clear to everyone? Can I ping 10.3 from R2? Ping 10.1.1.3. Will ping work? Ping is working. So DMVPN, you can see what happened. Spokes had discovered tunnel dynamically. Right. First packet has gone to headquarter. You can see ICMP packet. Source was 10.2. Destination was 10.3 in the ICMP packet. In the outer IP packet, source IP address is 2.2.2.1. My public IP address, destination IP address is 1.1.1. Right. Then GRE, inner IP header, and ICMP packet. It has sent to hub router. But hub router has sent one. But at the same time, the spoke router has sent one more message. NHRP resolution request message. First they had here registration request message, that is registration message, right? Spoke side has registered themselves to hub router in phase 1. In phase 2, spoke router has here which message? Resolution message, resolution request message, NHRP resolution request message. Actually R2 is going to ask to R1 that, bro, can you tell me the NBMA address of 10.1.1.3? It will send first ICMP packet to hub router, and back to back it will send one NHRP resolution request message. In the response, what happened? R1, your hub router, will send resolution reply message. In the resolution reply message, it will share what? You can see the destination protocol address is 10.1.1.3, and somewhere it will be sharing the NBMA address, right? Because hub router know this. Hub router has information in their NHRP table, IP NHRP. What is the NBMA address of 10.1.3? So here it is saying, you can see client NBMA address is 3.3.3.1 and client protocol address is 10.1.1.3. What router 2 will do? As soon as router 2 will receive this resolution reply message, R2 will update their NHRP table. So IP NHRP. Here you can see the dynamic entry for 10.1.1.3. This entry never expired because statically we have created this. But this is dynamic entry. It will expire after this time. This is dynamic in nature, right? R2 has learned it through NHRP resolution reply message by R1, right? And second packet, third packet, fourth packet, if you will see, these all packets are going directly to spoke 2. Here you can see it is going directly from 2.2.2.1 to 3.3.3.1. If anyone have any question here, please ask. If it is clear, say yes, clear, so that I can move further. All clear? Phase 2. Can I configure routing protocol here now? In LAN side, here we have this subnet 10.1.1.0, 192.168.2.0, 192.168.3.0, like this. Or I can say 10, 11.0 and 12.0. Yes. Can anyone tell me what is the issue in DMVPN phase 2? Any issue you guys can see? There is no issue in DMVPN phase 2. Issue will occur when I will configure routing. Now let me do one thing. Let me create loopback on router number 1 and let me enable EIGR. First let me configure EIGRP protocol over DMVPN. Router EIGRP ES number 10, no auto summary, and network 10.1.1.0 wildcard mask 0.0.255 exit. Copy, paste it on R1, R2 and R3. R1 config T, paste. R2 config T. Will EIGRP session come up? No, Praful. EIGRP is going to send message on multicast address. For multicast address, what will be the NBMA address? In outer IP header, how it will encapsulate IP packet into another IP packet. So you have to map multicast statically or dynamically. Again we have two options, IP NHRP map multicast. Here you can say dynamically, or you can configure statically. Statically, here I can say 2.2.2.1 and 3.3.3.1 on router number 2 interface. Or let me do one thing. I think in GNS3 dynamic is not working, but let me try once. Here I can say IP NHRP map multicast dynamically. See, it is still sending EIGRP packet on multicast address. Do so IP NHRP. IP NHRP map multicast into 2.2.2.1. Now it should send EIGRP message to 2.2.2.1 as well. Do so IP EIGRP neighbor. EIGRP neighbor is fluctuating. Do so IP EIGRP neighbor. Q count is 1. Interface tunnel 1. You have to configure static mapping. Dynamic mapping is not working here. Let me say on daughter number 1 first. 3.3.1 and I can remove this command, dynamic command. On R2 interface tunnel 1 and IP NHRP map multicast into 1.1.1. On R3 interface tunnel 1 IP NHRP map multicast 1.1.1. Now EIGRP session will come up. So IP EIGRP neighbor. Now Q count is 0. You can see there are two neighbor on R2. So IP EIGRP neighbor on R3. So IP EIGRP neighbor. Q count 0. But spoke 1 and spoke 2 don't have EIGRP neighborship. If I will configure one more mapping here, interface tunnel 1 and IP NHRP map multicast into 3.3.3.1. Sorry, 2.2.1, 2.2.2.1, and on R2, if I will say 3.3.1, interface tunnel 1, IP NHRP map multicast to 3.3.3.1. Will I have EIGRP neighborship between spoke 1 and spoke 2 now? So IP EIGRP neighbor. Yes, you can see the two neighbor, right? Because router 2 already know the NBMA address. So IP NHRP, in NHRP here you can see it has run through NHRP resolution reply message. So they have formed the EIGRP neighborship. If I will talk about my DMVPN is like this only. If I will talk about EIGRP neighborship, so we have one EIGRP neighborship over here. one EIGRP over here and one EIGRP over here. Full mesh EIGRP neighborship. What is the issue? Is there any issue till now? Yet there is no issue. Now let me create loopbacks. Interface loopback 1, IP address 192.168.10.1, 255.255.255.0, exit, copy, paste, interface loopback 2, IP address 11.1, interface loopback 3, IP address 12.1, copy it, paste it on R1, and one more thing, advertise it in EIGRP, router EIGRP as number 10, network 192.168.10.0, or I can say 0.0. Wildcard mask 0.0.0.0.255.255. It will enable EIGRP on all loopback interfaces. Copy and paste it on R1. If you will check, so IP EIGRP enabled interface, so IP EIGRP interfaces, you can see EIGRP is enabled on all the loopback interface and on the tunnel interface. For router number 2, spoke 1, here IP address is going to be 20, 21 and 22. Copy, paste it on R2. Great. Then for R3 it is going to be 30.1, 31, 32. Copy and I will paste it on R3. Done. So IP EIGRP interfaces. EIGRP is enabled again. Now if I will show the routing table, so IP route EIGRP, you can see 192.168.1.0, 2.0. These are already running, right? 1.0 in headquarter, 2.0 in branch 1, 3.0 in branch 2. Here are newly added networks 10.192.168.10.0, 11.0 and 12.0 and 20.1.20.0, 21.0 and 22.0. You can see the next hop IP address. These prefixes are reachable via which protocol address, which tunnel IP address. Right? So a spoke 1 prefixes is coming in a spoke 2 with a spoke 1 next hop. If I will show you the connectivity, ping 192.168.10.1, source 192.168.30.1. Ping is working. If I will ping 20.1, ping is working. 20.1 also means spoke. If I will trace route 192.168.20.1, source 192.168.30.1 and numeric. Traffic is going directly, right? And it has NVMe address. So IP NHRP. It has the NVMe address of 10.1.2. That's why it can send traffic directly. Now imagine you have 200 branches. In all the branches you have 10 number of prefixes or 3 number of prefixes. and I want to perform summarization here. What I want to perform summarization for site prefixes, like all the branches will advertise individual prefixes to DC, but DC will advertise summary address, like summary address of this subnet, these prefixes to branch 1, to spoke 1, and summary address of these prefixes to branch 2. If I will perform summarization on hub router, the next hop IP address for that summary address will change, and then spoke to spoke communication is not possible. Then again all the communication will start happening via hub router headquarter. DMVPN phase 2 is not much flexible for routing over DMVPN, right? One issue, you cannot perform summarization in the spoke side. Can anyone tell me the summary address of these three subnets? Summary address of these three subnet? अर्नब चले जाओ यहाँ से, आ रहा हूँ मैं थोड़ी देर में. Yes. Summary address between spoke 1 and spoke 2. Do we have tunnel? Yes. Which tunnel? Dynamic tunnel. We have dynamic tunnel, and everywhere in hub as well as spokes, GRE mode is multi-point in DMVPN phase 2. Issue in DMVPN phase 2 is only one. If one side is advertising 50 subnets to hub router and I want to summarize that, like, see, by the way, one more thing, if you have 200 number of sites, you will have many EIGRP session on spoke routers. So many time you will not configure EIGRP session between spoke 1 and spoke 2. You will not configure EIGRP neighborship between spoke 1 and spoke 2. This mapping is not required here. Where it is? Do so run interface tunnel 1. This mapping IP NHRP multicast 2.2.2. and on router number 2 interface tunnel 1, do so interface tunnel 1, do so run interface tunnel 1. Here also I will remove this mapping, right? With the help of resolution message, it can resolve the NVMe address to send the packet, IP packet, right? But now EIGRP session will not come up here. So IP route or so IP EIGRP neighbor. Now you can see spokes has EIGRP session with hub router. So IP EIGRP neighbor. If I will show you the routing table, so IP route EIGRP. Now Praful, spoke 2 sites prefixes, spoke 1 prefixes are not coming. Why not coming, guys? Why branch 1 routes are not coming in branch 2? Tell me. Split horizon rule. Because of split horizon, now R1 has neighborship with R2 and R3. So R2 will advertise these prefixes to R1 on tunnel interface. R1 will not advertise that from same tunnel interface. So here you have to know is disable split horizon rule. Interface tunnel 1. One more command. IP EIGRP IP next hop self for EIGRP as number 10. This command is running by default. Say no to this command. sorry, no IP split horizon command is IP split horizon for EAGRPS number 10. By default this command is running. I'm going to say no to this. Now if you will check routing table, so IP.EAGRP, now you can see side 1 prefix is coming 20.1, 20.0, 21.0 and 22.0 with next hop what? With next hop hub router. Now you can ask Praful, again communication will happen through hub side. No, first packet will only go through hub side. So IP route EAGRP, again here you can see next hop for all the prefixes is hub router. If I will trace route 192.168.30.1 and source 192.168.20.1 numeric traffic is going to headquarter, then headquarter to branch 2. See, we can solve this problem. How we can solve this problem? We can tell to router number 1 to not modify the next hop IP address, right? IP next hop self for EAGRPS number 10, I can say no to this command. Now if you will check a routing table, so IP route EAGRP, you can see these prefixes, 30 prefixes are coming with next hop R3 tunnel IP address, and on router number 3, so IP route EAGRP, you can see 20 prefixes are coming with R2 tunnel IP address. Problem solved. Now if I will trace route again from R2, maybe first packet will go through hub router if NBMA address of R3 is not available, but NBMA address is already available. You can see traffic is going directly to branch 2 spoke 2. Very good. Now I want to reduce the size of routing table in spoke router. I want to advertise summary address of these prefixes. Who will tell me summary address of 20.0, 21.0, 22.0? हाँ जी. How to configure summarization in EAGRP? How we configure summarization, guys? Am I audible?
Yes, audible.
Yes. How to advertise summary address in EAGRP? Summary address is going to be /22, means 192.168.20.0/22.
22. Yes.
192.168.20.0/22. This is what summary address. I want to advertise this summary address instead of advertising these all individual prefixes to spoke to. How to advertise that? IP summary address for EAGRPS number 10 is 192.168.20.0, and what will be the wildcard mask or submit mask? 252.0. 252.0. Now go to R3 and show IP route EAGRP. Now you can see one summary route is coming right for branch 2, and next hop IP address for this summary address is changed. Now if you will trace route from here, trace route 192.168.20.1 and source, let's say loopback 1 numeric, traffic is going to headquarter. Now for the summary route, all traffic will go via hub router only because of next hop IP address. As we have performed summarization on hub router, now we cannot update the next hop address here, right? DMVPN Phase 3 can solve this with the help of redirect feature. like ICMP redirect feature. When router 1 will see, okay, someone is using suboptimal path, what will happen? R1 will send one NHRP redirect message and will share the next hop IP address. So just you need to add one more command in DMVPN phase 2 to configure DMVPN phase 3. On hub router, you have to configure NHRP redirect feature, and on the spoke router shortcut feature. I think that command is not available on this router interface tunnel 1 and IP NHRP redirect is available. Redirect warning, NHRP redirect failed to initiate. This router doesn't support NHRP phase 3. Here we have another router, we have to replace it. Do so interface, do so run interface. Tunnel 1, copy. I'm going to paste all the commands over here. I can replace this router. And let me say shortcut command should be available here. Interface tunnel 1 IP NHRP shortcut. Okay, it is working. So only I need to replace hub router. Let me configure underlay. IP address 1.1 255.255.255.0 IP route 0.0.0 0.0.0 F 0/0 and 1.2 do ping 2.2.2.1. Ping started working. Let me copy the commands of tunnel interface. Let me paste it over here. All the commands are accepted. Now router EAGRP AS number 10 network 192.168.0.0 and one more network command 10.1.0 0.0.255 auto summary, then interface tunnel 1. Okay, tunnel 1 interface is already configured. So IP route EAGRP, so IP EAGRP neighbor q count is 1, so run interface tunnel 1 IP NHRP. Okay, mapping is done for 10.2. No, it's incomplete, right? It's incomplete. So go to R2 interface F0/0 shutdown and no shutdown, so that it will send NHRP registration message again. R3 interface F0/0 shutdown and no shutdown. You can also change NHRP timer, right? Now so IP NHRP, still it's incomplete. One entry is incomplete. One NVMe address is installed. Soon R3 will also send registration message. Shutdown and no shutdown. R3 is not sending NHRP registration message. IP NHRP interface tunnel 1 IP NHRP registration timeout. Done. Entry is updated here again. So IP EAGRP neighbor, again EAGRP neighbor chip is up. So IP route EAGRP, all the prefixes are coming. Some route is also there. Go to R2. So IP route EAGRP. Okay, and on R3, so IP route EAGRP. Here you can see only summary address is coming, right? These loopbacks are not created in headquarter now. Great. Summary address is coming from branch 1. So if you will trace route again, trace route, see the traffic is going via headquarter. Now we can enable DMVPN phase 3. Here interface tunnel 1 IP NHRP shortcut, R2 interface tunnel 1 IP NHRP shortcut, and R1 interface tunnel 1 IP NHRP redirect. Go to R3 again, and now you can trace route. And before that, you can capture this link also if you want to see the redirect message. Trace route, traffic is going through headquarter. Now you can see second time traffic is going directly. So what happened here? Here you can see after first ICMP packet. Okay, for trace route UDP packet, first router 3 has generated UDP packet, router 1 has generated ICMP packet with like ICMP error message, TTL exceed. Second UDP message, what happened? Here is NHRP redirect message. Here you can see 1.1.1 is sending to 3.3.3. What it's saying, if you will open this NHRP message and mandatory field, here you can see somewhere you will see that redirect message UDP somewhere it will be saying NVMe address redirect NHRP redirect message R3, so IP NHRP 192.168.30.0 20.0/24, and here you can see the protocol address. NVMe address is 2.2.2. In the capturing it is not showing the exact output, but here we can verify it here, right? And now with the help of traffic also we can verify that traffic is going directly. It means what? It means R3 now know the NVMe address of R2 and how to reach 192.168.20.0/24 directly, like for the destination 20.0/24. For the destination, what will be the tunnel IP address, tunnel protocol address, or you can say tunnel IP address. And this is what? DMVPN phase 3. But what is happening here, if I am pinging ping 192.168.20.1, here you can see the capturing. Data is going in plain text, right? Everything is visible. Anyone can read it. What next? Now configure ipsec here. ipsec to encrypt the data. Again, ipsec works in two phases, phase 1 and phase 2. Phase 1 is used to create a secure channel. Phase 2 is used to encrypt the data. Guys, there are some parameters in ipsec: ISACAM policy, preset key, transform set, ipsec profile. So right now I am not discussing ipsec, just I am configuring ipsec here to encrypt my data. R1, configure the crypto ISACAM policy number 10 or 1, any number, and here we will define the algorithm. See, remember one thing: to create any secure channel you need three things. You need three things: encryption, hashing, and pre-share key. Without these three things you cannot create any secure channel. So encryption, hashing, these are nothing but algorithm. Like I had discussed checksum in Ethernet header. I had told you checksum is similar like juicer. If you will give apple, it will give you the apple juice, right? Similar, it is algorithm. We have multiple algorithm for encryption, like DS, 3DS, ES, advanced encryption. So these are different algorithm. I will talk about the encryption hashing later. For now, just I'm configuring. Hashing algorithm can be MD5 or it can be SA, right? Then authentication, how you are going to authenticate the peer. For that I can use pre-share key, or you can use the certificate, digital certificate. There is group number as well. Let's say group number 2 and lifetime. This one, do so history. These parameters should match on all the router. That's why I have copied the command and I am going to paste it on other router as well. R2, no worry about these commands. This is ipsec SA, security association. My encryption algorithm is AES. Hashing algorithm is SA. Hashing provide integrity. Encryption means it will change the text in ciphertext. And pre-share is going to authenticate the peer. Group is Diffie-Hellman group, if anyone know Diffie-Hellman key number. And lifetime is assay duration, right? Like after what time it is going to negotiate the assay. All security parameters, security association. All the routers are going to negotiate these security parameters. It should match. Now we'll configure pre-share key, and key should also same. So here exit. Your all IPsec configuration or security related configuration on the router will start from crypto. Most of the command crypto, ISACAM key, and here I can define the key. Let's say key is admin @123, and you are going to authenticate whom with this key. You are going to authenticate which peer. So here you will define the address. And then address. Here I can define the peer IP address, NBMA address, or you can say 0.0.0 means all the peer. You can authenticate all the peer like this. Here your password is admin@123. So let me copy this command and let me paste this command on other router as well. Now we'll configure transform set. We'll set transform set. Like transform set is going to define how traffic will be encrypted. How your traffic will be encrypted. So R1, on R1 again command will start from crypto ipsec transform set, and transform set name, let's say PM set or key set, or only let's say PM. And here like how it will encrypt the traffic, what encryption algorithm it will use? AES to encrypt the data. First we have defined the encryption algorithm for phase 1 to create secure channel. Now we are defining algorithm to encrypt the data, right? ESP, and here SA history, do so history or copy the command. Transform set name is PM, just keep in mind this. Done. See in this configuration what I say, ESP is encapsulation security payload. So payload will be encrypted with the help of this algorithm, right? AES for encryption and SA for packet integrity, like for hashing, right? It mean what? It mean encrypt packet using AES and verify integrity using SA. What it mean? What I told you, transform set means how your traffic will be encrypted. And with the help of this command I have defined router use AES for encryption and SA for integrity, like no one has modified the data. Now in next step we are going to create a security profile like ipsec profile, and then we'll apply that on the tunnel interface, right? So go to R1 again, exit from here and create one ipsec profile, crypto ipsec profile. Name of profile is let's say DMVPN profile, DMVPN profile, and here set transform set, call your transform set. Name of transform set was PM, do so history, copy, go to R2, paste it over here, go to R3 and paste it over here, right? So you can think of profile as a like what we can say, like a container, right, which contain all the algorithm of transform set inside PM. Now in last step we are going to apply this security profile or IPsec profile on the tunnel interface. This is the most important step. Until and unless you will not apply it on the tunnel interface, it is not going to encrypt any data. So go to R1 again, exit from here and say interface tunnel 1 and tunnel protection IPsec profile. And what was the name of my profile? Name of my profile was DMVPN profile. Copy it. DMVPN profile, enter. Do so history. In DMVPN you cannot learn IPsec, right? You will learn IPsec separately. Here just I have configured. Right, later when we will discuss IPsec between two sites, you will understand it in more better way. Now again, if I am going to send traffic, see, ping 20.1.1, sorry, ping 192.160.20.1 and source loopback 1. And where is my capturing? Is capturing working? Yes, it's working. You can see ESP packet. Now let me send ICMP packet. Let me send 1000 ICMP packet. Repeat. You can see. Is anything visible? Even the EIGRP packet, nothing. Right now on the tunnel interface, you will have this traffic. If you will open it, you can see security payload, encapsulating security payload. Like everything is encapsulated. What ipsec does? ipsec is going to encapsulate entire packet, IP packet. First it will encrypt everything, encrypt, and then it is going to encapsulate it in ESP packet. And here in the capturing you can see it. Right, after lifetime even it will be exchanging the key. Like there is lots of concept, guys, inside the ipsec. Soon we'll discuss that, like how it is secure, how attacker on the internet cannot decrypt this. Until attacker can find the key, routers are going to change the key.
Sir,
Yes.
Wanda, at this time, as do we have any means to see the message inside the encryption?
No, you cannot see.
Even the admin couldn't see.
Yes, admin can also not see.
Okay, thank you.
Only router can decrypt. Like when traffic will reach to site 2 or router 2 is going to decrypt. Only routers know the key to encrypt and decrypt. Right? You will learn that in IPsec session. No worry. And router 2 will send again normal ICMP packet from this LAN interface. Here you can, there are some verification command. Here you can see you can verify the ISACAM security association, right? And what we can say, like tunnel, you can see tunnel is established. So crypto ISACAM SA. Similarly you can say check IPsec SA as well. IPsec security association. Here whatever algorithm you have configured, similarly you can verify over here. And this command is used to verify phase 2, and ISACAMP is phase 1 security. So this is phase 1. This is just secure channel, right? You can see 1.1.1 has one secure channel with 2.2.1 and one with 3.3.3.1. When you will send traffic ping, and even this tunnel is going to be idle when users are not sending traffic. Tunnel will be not active always. It will be in idle state, like in sleeping state. And whenever router will receive traffic for the tunnel, your secure channel will activate and it will perform encryption. Again it will go in idle mode. Ping 192.168.20.1 and source loopback 1. What happened? Source interface loopback. Okay, F0/1. No problem, you can ping directly like this because next hop IP address is tunnel only. Right, like so IP route 192.168.20.1. You can see exit interface is tunnel interface. Whenever exit interface will be tunnel interface, it will perform encryption. Right, so this is basic IPsec configuration over DMVPN. Similarly, you can configure IPsec over GRE as well. And the most important thing, we can configure pure IPsec session between sites as well, right? So first we'll understand now IPsec between sites without having GRE or DMVPN. Without having GRE or DMVPN, how IPsec can create VPN and it can encrypt the data as well. That is going to be your pure IPsec. IPsec without GRE, not GRE over IPsec or not IPsec over DMVPN. Pure IPsec. Okay, so today we have covered DMVPN phase 1, phase 2 and phase 3, and we have implemented IPsec to encrypt our data. Hope it is clear. If anyone have any question here, please ask.
Just to know in which book can we read about these things?
In CCNP book,
Okay. Do
you can
you
download the
remember
router
the
LA notes.
chapter?
Download router LA note for DMVPN. That will be best.
Can you repeat?
Router LA note for DMVPN. DMVPN router.
Ale, okay. Thank you.
You can download his notes for IPsec as well.
Okay. Thank you.
I think this is better, right? To get the summary notes. Anything else, guys? But these are our traditional WAN, legacy WAN, right? Not the modern WAN. These WAN are not designed for cloud applications. If I am going to connect cloud here, right, then user will get poor experience during accessing cloud applications. Later when you will learn the modern WAN, you will understand those things as well, right? You have to learn everything. First you are learning traditional WAN, later you will learn the SD-WAN. So nowadays companies are using SD-WAN to connect multiple sites. Still in the production you will find DMVPN, and earlier before SD-WAN this was very popular. DMVPN over internet and MPLS L3 VPN over service provider. Okay sir, then that's all for today.